Hi guys, this is an exercise concerning the sequences and was given in exam June 2021. We have a sequence un which is defined by u0 equals 1 half and un plus 1 equals un over 3 minus 2 un for each natural number n. Let's begin with first question, calculate u1. To find u1, we just use the definition of the given sequence. So u1 equals 1/4. In question 2, we use the induction to prove that for each n belongs to n, each term of the sequence between 0 and 1 half. Step 1. We verify that the given frame holds for n equals 0. So for n equals 0, we have u0 equals 1 half. So 1 half is positive and smaller than or equals 1 half. So u0 between 1 half and 0. Step 2. Let n be a natural number. We assume or suppose that un more than 0 or greater than 0 and smaller than or equals 1 half, and we prove that un plus 1 also between 1 half and 0. We have un between 0 and 1 half, f and only f. The idea of this step, we build un plus 1, or we frame un plus 1 by using un. So we multiply by -2, we get -1 smaller than or equals -2 un smaller than 0, because we change the direction of this frame because we multiplied by negative. After that, we add 3. So f and only f, 3 plus -1, which is 2, smaller than or equals 3 plus -2 un is 3 minus 2 un, smaller than 3. After that, we switch the top and the denominator. We have 1/3 smaller than 1 over 3 minus 2 un, smaller than or equals 1 half. Then we multiply this frame by this frame. So we get 1/3. So we multiply side by side. So 1/3 times 0 smaller than 1 over 3 minus 2 un times un smaller than or equals 1 half times 1 half. So we get 0 smaller than un over 3 minus 2 un smaller than or equals 1/4, which is smaller than or equals 1 half. So we conclude that un plus 1 bigger than 0, smaller than or equals 1 half. In step 3, we write the conclusion. In question 3, subquestion A, show that un plus 1 over un smaller than or equals 1 half for each natural number n. First, we simplify the fraction un plus 1 over un. So for each n belongs to n, we have un plus 1 over un equals. By the definition of this sequence, un plus 1 equals un over 3 minus 2 un, all of them over un, equals. By the division of the fractions, so un over 3 minus 2 un. The division becomes multiplication of the inverse multiplicative of the denominator. So we have 1 times 1 over un. We cancel un with un. 1 over 3 minus 2 un. Then by using question 2, we will try to find the frame of 1 over 3 minus 2 un, which is un plus 1 over un. By equation 2, we have 0 smaller than un, smaller than or equals 1/2. F and only f, we multiply by -2, we get -1, smaller than or equals -2 un, smaller than 0, f and only f 2, smaller than or equals 3 minus 2 un. Basically, we add 3, so 0 plus 3, which is 3. After that, we switch the top and the denominator to get 1/3 smaller than 1 over 3 minus 2 un, smaller than or equals 1/2. We can rewrite it like 1/3 smaller than 1 over 3 minus 2 un is un plus 1 over un, smaller than or equals 1/2. So we conclude that un plus 1 over un smaller than or equals 1/2 for each or every n belongs to n. In question 3, sub-question B, deduce the monotonicity of the sequence un. So after the previous question, we have after the question 3a, we have for every n belongs to n, un plus 1 over un smaller than or equals 1/2, and also each term of the sequence is positive. From question 2, okay, we have un between 0 and 1/2, so each term of the sequence is positive. We can write un plus 1 over un greater than 0. So in this frame, we already know that 1/2 is smaller than 1. So un plus 1 smaller than or equals un times 1, which is un, for all n belongs to n, which means that this sequence is decreasing. For question 4, sub-question A, show that for every natural number n, un is between 0 and 1/2 power n plus 1, and then calculate the limit of this sequence. By induction, we can prove that un is between 0 and 1/2 power n plus 1. So, step 1, for n equals 0, we have u0 equals 1/2 and 1/2 power 0 plus 1 equals 1/2. So u0 is strictly positive and smaller than or equals 1 over 2 power 0 plus 1. Step 2, let n belongs to n. Suppose that un between 0 and 1/2 power n plus 1, then prove that un plus 1 smaller than 1/2 power n plus 2 and positive. Okay, we have un between 1/2 power n plus 1 and 0. And from question 3a, we have un plus 1 over un smaller than or equals 1/2 and strictly positive. If we multiply these two frames, we get 0 smaller than un times un plus 1, un times un plus 1 over un smaller than or equals 1/2 power n plus 1, and here we have 1/2 power 1, so n plus 2, which means that 0 smaller than un plus 1 smaller than or equals 1/2 power n plus 2. In step 3, we write the conclusion. To find the limit of this sequence, we use the previous frame. So we have, for all n belongs to n, un between 0 and 1/2 power n plus 1. And we have limit of 1/2 power n plus 1 when n tends to plus infinity equals 0, because 1/2 between 1 and 0. By use the sandwich method, we conclude that the limit of un equals 0. For question 4b, we have Vn equals ln of 3 minus 2 un, and we need to find the limit of Vn. So since limit of un equals 0 from the previous question, then the limit of 3 minus 2 un equals 3 minus 0, which is 3. Also, we have the logarithm function is continuous on 0 plus infinity, and here we have 3 belongs to this interval, which means that this function is continuous at 3. Therefore, or thus, so limit of Vn equals ln 3. In question 5a, we verify that 1 over un plus 1 minus 1 equals 3 factor 1 over un minus 1 for each natural number. So we have, for each n belongs to n, 1 over un plus 1 minus 1, which is the left-hand side of the relation. And here we have un plus 1 equals un over 3 minus 2 un. So 1 over un plus 1, this term, is the inverse multiplicative of un. So we have 3 minus 2 un over un minus 1. After that, we just calculate the result by using the common denominator. So we have 3 minus 2 un. Exactly, we multiply by un in the top and the denominator to get 3 minus 2 un minus un over un. After that, we simplify the top. We get 3 minus 3 un over un. We get 3 over un minus 3 un over un. We get 3 over un minus 3. And then we take 3 as a common factor to get the desired result. In question 5b, we have to deduce un in terms of n for every natural number n. So from question 5a, we have for each n belongs to n, 1 over un plus 1 minus 1 equals 3 factor 1 over un minus 1. Look at here, we have the same expression here, 1 over un minus 1, 1 over un plus 1 minus 1. We can say that there is an expression of 1 over x minus 1. So here we can suppose that, or we consider a new sequence, the sequence wn defined by wn equals 1 over un minus 1 for each n belongs to n. And then we get that wn plus 1 equals 1 over un plus 1 minus 1. Okay, so we conclude that, or we deduce that, this sequence wn is a geometric sequence Why we say that? Because here we can write wn plus 1 equals 3 times wn for each n belongs to n. Okay, this sequence is geometric. What is the common ratio? So with common ratio, q equals 3. With first question, w0 equals 1 over u0 minus 1, and here we have u0 equals 1/2, so 1 over 1/2 minus 1 equals 2 minus 1, which is 1. So we can write wn equals w0 times q power n for all n belongs to n, and we replace the ratio and first term to get finally wn equals 3 power n for all n belongs to n. That's all about this exercise. Thank you.